So I think this is the second time that I speak to you with a presentation and things like that. I remember when I started working in this lab that maybe Katarina or someone else do a quick tutorial on how to write our code with best practices, and I like that idea. And also, I think that through this year of working with you, I learned a lot of things, and I think the best way to show you what I learned is to try to show you how you can do the same that I did in this year. So that's the main idea of this talk. So today I'm going to show you how you can start creating packages to share your code. Believe it or not, you already know how. My name is Jesus Val Santiago, and that's it. So let's start. Do you recognize the following pattern? If you answer yes, that's probably because you are one step ahead of what we need to do, so you can skip this. For instance, what you need to do to create an R package is pass from this scheme and you're to this. Instead of using a script folder, you need to use an R folder. Then what about the data? For the data folder, it can remain unchanged, which means that you don't need to worry about it. I mean, if your data is huge, maybe you need to host it in another platform. But if it's a minor data set, you can keep it inside of the data folder. Then for the reports that you write, instead of call it reports, you are now calling it vignettes. And that's almost everything that you need to know for now. But there is also a huge step next. That is create a man folder that would represent the full package documentations, but you don't need to worry since always that you write code, you write comments about what the parameters do and things like that. So R, it's intelligent and generates this for you, so that you don't really need to worry about it. Then you need to write tests. A test is a automated code to test your package functionality. You already know. You already know how to do this. I mean, when you write code and then something fails, you see an error throw, and then you say, okay, this is not work. Why this is not working? And then you go inside of the code and try to fix it. Well, that's what test does. So you already know how to create tests. Then the description file is where all the metadata about your package go. I mean, the version of your package, your title of the package, what your package stands for, what libraries you need, and things like that. The namespace indicate what need to be exposed to the user of your package, but you don't really need to worry about this too, since R is going to generate it for you. Then you can change the name of the project. Instead of your awesome project analysis, you can call it your awesome package, right? And that's almost everything that you need to do. And I'm quite sure that you know all of this. So how to do all of this? But wait, should I manually do this every time? You're right, you don't. Programmers are lazy, and I'm lazy, and people don't like to do the things manually. So people create packages to share their knowledge and share their tools to help other people. So this is why use these packages exists. Use this is the blessing behind it all. Science allows you to create package with a single line. You can use this create package, then your name of your package. I'm going to create a new project with a new R folder with their description, the version. So you only need to worry about the code, why it's important to us just to write the code. We don't want to worry about other things. So the process can be a speed up. This is a basic package if you use this function, but then you can create a tidybears-like package. I mean, with the standards of the tidybears, how to document your code, how to create your code with guidelines of a style. Use this create tidy package. So you are going to, behind the scenes, you are going to run in to create a test.dat folder, to include a license, a tidy description, a README, and things like that. So it also going to link your project with a GitHub project. So that's good since you don't need to worry about another thing that you probably don't want to do manually. And then what is more important to us here is probably that at some point you are going to create packages for the bioconductor. So what you need to do if you wanna do that. So if you want to develop packages for the bioconductor, instead of using just this, you're probably going to use BioC, this package that is developed by Leo Collado, which creates a folder with steps in which you can follow and then create a package with the bioconductor standards. Since the tidyverse and the bioconductor share a lot of recommendations to follow, personally, I recommend you to first use this create tidy package and then follow the instructions by Leo Collado using the BioC package templates. And that's it. So at this moment, you created a package that is functionally, I mean, it doesn't have any function, but you don't need to worry about the structure of the project and things like that. So you can now just focus on what matters, the code. So what about the code? Should I rewrite all my code that I did before? I mean, I was working with analysis, what I need to do to convert it to a functions for a suitable for a package. You don't need to worry, you're almost there. In fact, you'll be doing all this time again, but you haven't realized it. And there is a phrase for a new way from Kung Fu Panda: one often meets his destiny on the road he takes to avoid it. So probably you've been saying that you don't know how to create a package, and instead you are creating a package like with the folder structures, but without the benefits of a package. But the thing is that you already do it, and you already know how, and I show you how this works. So we need to transform your code. The first step is to look at your code. In this case, I am summarizing the iris dataset to calculate the mean of the sepal length and the sepal width. So the first thing is to create a new R file using the use R function. Good stuff here. That's what I call this file. So this will create an empty file, and also we're going to suggest you to create an automatic test, but we can keep it until here for now. Then what you need to do is to abstract your code inside a function. Here I am just wrapping my function to summarize the iris inside of a empty cop2 function. The next step is to declare the dependencies. But you already know how to do that, since all the time that you are working with our package, you are always using this library, dplyr library, tidyverse library, pour, and things like that. So you already know how to declare your dependencies. What you need to do is comment this or delete this line, and then instead of this, you need to use the package double column function notation to call your functions. This is a special way to reference where the function comes, and to include this dependency in your package. And don't worry about the things that you need to do. You can just use package dplyr, and then this would create a new entry in your description file for you, so that you don't need to worry about it. And then further step could be try to generalize the function or try to abstract the function. Before, I only can summarize my iris data set by species and only by the petal and the sepal length. Now, with this generalized function, I can pass any table, and then group by any variables, and then pass a list or a vector of variables for which I want to calculate the mean. So in this way, the function is more reusable, and we can use it along the package without worrying about what is happening inside, or about specificities that probably some people doesn't fit, and then your function is not gonna work. In this way, you ensure reproducibility at other level. So, but also sometimes it's not possible and it's not convenient for you, so you can skip this step and remind as before. Then you need to write a test. As I mentioned, you already know how to do this. With the use this package, you only need to use the use test function with the name of the test that you wanna create. And then inside of this, you are going to write code like this. Test that, a name for your test, multiplication works, and then a speed equal function. I am expecting that 2 plus 2 or 2 times 2 is equals to 4. If that is true, then your package passed. If no, your package fails. This will create a more flexible package, since you can enter to the code of the package and then edit it, modify it, and then if something goes wrong, you can know where this happens and how to fix it more easily than don't creating packages. So you need to start creating packages. You already know how, so I encourage you to do so. Here is a little shortcuts that you can use to create a package. The load function will instantiate your package like you do library. Your awesome package will load it so you can access to all of your functions. Then DevTool test will run all your automatic tests like this or multiplication works. Then DevTools will how to compare how your package builds, and then you can import it normally like library dplyr. And then a huge and important function, DevTools document, that is the one that is going to create the full documentation of your package. So keep this in mind if you want it. Then when writing code, you're always collaborating with future you, and past you doesn't respond to emails. So you always need to try to write code that you can understand without too much thinking. If you keep it simple, it's probably that 6 months later, you enter to see your code and you know what the code does. So this is very important. Take a note to yourself. So a simple recapitulation, we pass from a data directory structure like this to something like this with vignettes, an R folder with amount, with test, description, and namespace. Then we pass from code that we normally write like this in line to write generalized functions that can serve to multiple purposes, not only the original that we are looking for. If you already write functions, then there is almost you almost do everything that you need to do. So if you every time that you write functions, then you can only copy and paste your functions inside of the R folder and use this nomenclature package, and then you have everything that you need. Being further of this, you can write documentation. I mean, this is what I talk about. You can say, I want to export this function, define what the parameters it stands for, a title for your function, and what the function does. So keep it simple. You already know how to do that. It's just another nomenclature, but you already know how. Then you need to write unit tests. With the use test, write a new test, run your automatic test with DevTool test function, and then you are going to see something like this. And that's almost everything that you need. In your description file, this at the end of this will look like this. Your awesome project, what the package does, in one paragraph. You can write your own description, specify the authors. And I want to point you to this line, that is our oxygen lights markdown equals to true, which would allow you to create this kind of documentation using plain markdown. So any person that entered to your documentation can read it instead of the ugly way to create documentation using /code, wrapping your variables and things like that. So you can write plain markdown to to your package documentation. And then we had an import section which stands for all the package that you need. And that's a huge progress. And I want to close this talk with a with a phrase of Uruguay that is, yesterday is history, tomorrow is a mystery, but today is a gift, and that is what it's called, the present. So thank you everyone for giving me this time to talk to you about what was my part of learning inside of your group in this year. I really appreciate it too much. I would like to thank you to everyone and offer a sincere thanks to my advisors in this year of research, for Julio, to Rico, Christian Hollis that support me all the time, even when I ask too much. So thank you everyone for being here. Any questions?
Thanks. Just quickly, can you repeat what the load all function was doing? Because I used a lot the three others, but this one I actually never used it.
Yeah, what DevTools load all does is to, instead of you need to build and then import your package, when you are creating a package interactively, you can run DevTools load all to test the current changes that you do. I mean, if I write this function,
okay,
and then I want to test, I add a new line that it's called mutate or something like that, and I want to test how or see what these new lines do to my previous code, and can run load all and load the new version of my function. So I don't need to build it again and then test the function. It's a shortcut to doing so. So it makes create packages more fluently.
Okay, thanks.
Yeah. Anyone else?
So I wonder, I mean, first, thanks, Jesus. This is very helpful. And through these months with us, you had helped a lot with a lot of the packages and trying to support and convince people to follow these strategies. But I wonder more now for the rest of the people. Like, I know some of you follow this, but most don't. What, I don't know. What would you like to ask Jesus, or would you like to share what are the hurdles in using this